This video is going to talk about the mean absolute deviation of numbers. And what that is it's the average distance between each data value and the mean. And what you're going to realize about this is that there are going to be a lot of numbers involved and there's going to be a lot of steps involved. This is going to need a lot of little calculations. So rather than you watching me add and subtract numbers or watching me punch numbers on a calculator, you're going to notice that I'm going to do a lot of this work off screen and just bring it in. So you're going to need to pay attention to every little thing that I'm saying, and if you have to rewind a little bit to figure out where I'm coming from, don't be afraid to do that. But I am going to try to show as much work in the least complicated method possible, possibly. What you might need to do is you might need to show more work in order to keep everything straight in your head on this, and that is okay. Well, let's not even look at that. Well, yeah, let's do that. We're just going to go for a ride. We're going to start off by looking at these 5 numbers. And what we want to know is we want to know how far are these numbers away from the mean. So in order to figure that out, the first thing that we need to do is figure out the mean. So I'm going to go ahead and add 3 plus 5 plus 2 plus 6 plus 5. And when I add all of these numbers up, I'm going to get the number 21. And I'm going to take that number and divide it by 5 because there are 5 numbers that I've just added up. 21 divided by 5 is 4.2. And that is my mean. 4.2 is the mean. And that's going to be an important number for us to keep track of. Now what I want to do is I want to take a look at each one of these numbers, the 3, the 5, the 2, the 6, the 5, and I want to try to figure out how far away from 4.2 is each one of these numbers. So to figure out how far away 3 is from 4.2, I'm going to take the absolute value of 3 minus 4.2. So that is going to be 1.2. If I add 3 plus 1.2, I will get 4.2. Let's go ahead and let's look at the next number. 5 minus 4.2 is going to be 0.8. And you can see that I'm showing my numbers directly below each number so that I can follow where I'm coming from. The absolute value of 2 minus 4.2 is 2.2. If I add up 2 and 2.2, I will get 4.2. Just like if I subtract 5 minus 0.8, I will get 4.2. I just want to know how many steps does it take to get from this number to 4.2. And just like if I ask you how far is it to the grocery store, you're not going to tell me, well, it's negative 6 miles. You're just going to tell me 6 miles, which is why we use the absolute value here. 6 minus 4.2 is 1.8. And 5 minus 4.2, again, we've already done that, is going to be 0.8. Now, I have each one of these numbers. The distance from this number to 4.2 is 1.2. And we keep going. Now what I need to do is I need to figure out the mean of these numbers. I want to figure out the mean of the distance. So I'm going to go ahead and I'm going to add 1.2 plus 0.8 plus 2.2 plus 1.8 plus 0.8. And I'm going to end up with 6.8. And now, because I'm looking for the mean, I'm going to take this 6.8 and I'm going to divide it by 5 because there are 5 numbers here. 6.8 divided by 5 is going to be 1.36. So, on average, each one of these numbers is 1.36 steps away from the mean. That seems very complicated, and it seems like something you might not ever have to know. So we're going to look at an example over here. We're going to compare one set of numbers to another set of numbers, and we're going to see where does the data vary more. If the number is higher, then we know that the data is going to be more widespread. And if this number is smaller, we're going to know that the data is more joined up together and is more closely related. So we're going to come over here, and we have two sets of numbers here. This is the temperatures taken at two different times of the day. We have temperatures taken at 10 a.m. and temperatures taken at 2 p.m. And what we're going to do with this information is we are going to find for each one of these sets the mean absolute deviation. So let's go ahead and let's start off with the 10 o'clock set. So they took the temperatures at 10 o'clock for 6 days, and they got 55, 54, 50, 61, 54, and 49. In order to find the mean, we need to add up all of these numbers and then divide by the amount of numbers that we added. So in this case, it's going to be the sum of all of these numbers divided by 6. So first, let's add up all of these numbers, and we add up 55 plus 54 plus 50 plus 61 plus 54 plus 49. We're going to get 323. Because there are 6 numbers, we're going to divide that by 6 so that we get 53.83. And technically that number repeats, but we're going to round so it's just 53.83. Now for each one of these numbers, what I'm going to do is I'm going to figure out how far are they away from 53.83, and I'm going to put my little rectangle around there so I remember it. So how far away is 55 from 53.83? Well, when I subtract it, I'm going to get 1.17. How far away is 54 from 53.83? That's going to be 0.17. How far away is 50 from 53.83? That's going to be 53.83 minus 50, and that's going to be 3.83. How far away is 61 from 53.83? Well, in order to do that, we're going to do 61 minus 53.83 and get 7.17. How far away is 54 from 53.83? We already did that one. That's going to be 0.17. And 49 from 53.83 is going to be 4.83. So now we have all of these numbers, and now we need to find the mean of all of these numbers. So I'm going to add up these 6 numbers to see how far away do these numbers stray from the mean. When I add up these 6 numbers, I'm going to get 17.34. And I'm going to divide that number by 6 because there are 6 of them. When I divide that number by 6, I'm going to get 2.89. 2.89 is the mean absolute deviation. So the average amount of distance between this number, or these numbers, excuse me, and this number is 2.89. We're going to do the same thing with the 2 o'clock times. So, first thing we need to do is we need to add up all 6 of these numbers. 74 plus 74 plus 84 plus 71 plus 82 plus 65. When we add up all of those numbers, we're going to get 450. Because there are 6 numbers, I'm going to divide that by 6. 450 divided by 6 is going to be 75. The next thing I need to do is I need to figure out how far away from 75 are each of these numbers. So 74 is 1 away from 75. 74 is 1 away from 75. 84 is 9 away from 75. 71 is 4 away from 75. 82 is 7 away from 75. And our last number, 65, is 10 away from 75. Now we need to go ahead and we need to find the mean of these numbers. So we're going to add up 9 plus 1 plus 10 plus 4 plus 7 plus 1, and we are going to get 32. I'm going to divide 32 by 6 because there are 6 numbers here. 32 divided by 6 is going to be 5.33. And what we see when we compare this mean absolute deviation to this mean absolute deviation is that in the 10 o'clock hour, the numbers don't really stray that much away from the mean. They're all kind of close. Not all of them are like super close, but on average, they're closer than these numbers. On average, we only have 2.89, and on this side, we have 5.33. So on average, these numbers tend to be more varied than those numbers do. What you're going to do for your homework is you are going to answer the question, what causes a higher mean absolute deviation? What causes this number to be bigger